Automatic detection of cyberbullying in social media content. Social media has a great impact on the way the current societies are shaped. The anonymous and unrestricted nature of social media platforms results in increasing number of cyberspace crimes, such as cyberbullying and hate speech. Cyberbullying is considered one of the major negative impacts of social media. The percentage of cyberbullying has increased in the recent years, affecting many people around the world, especially the youth and the vulnerable. Here are some statistics about cyberbullying. 84% of social media users were cyberbullied worldwide. 60% were cyberbullied in the GCC, and 64% who were cyberbullied lost their ability to learn and feel safe. Our problem is, given an online written dialectical Arabic text, the goal is to accurately predict if it contains cyberbullying or not. Our solution is a system that improves the filtration of Arabic social media content by using machine learning, deep learning, and natural language processing techniques. The cyberbullying definition we used by Smith: an aggressive, intentional act carried out by a group or individual using electronic forms of content, repeatedly and over time against a victim who cannot easily defend him or herself. The figure shows the workflow of our project. First, the data collection stage. We collected our data set from YouTube comments with different video types, such as kids videos, gamers, makeup artists, vloggers, and general videos to make our data set more generalized. After that, the data annotation part, we followed some guidelines, such as the definition of cyberbullying, discussing it with specialists in the field, and majority votes. After dataset collection and labeling comes the pre-processing stage. In this stage, we experimented with different pre-processing techniques, including cleaning, normalization, and lemmatization. After that, we split our data into training, validation, and testing sets. Then we built our models. In this stage, we built two shallow learning models, SVM and logistic regression, and feature selection algorithm, TF-IDF, for numerical representation of our data. We also built two deep learning models, RNN-GRU and CNN, and we trained our own word embedding, and we used pre-trained one for our data representation. Finally, we trained and evaluated models. Our contribution is we collected 13,000 comments dataset, and for the result, we achieved an accuracy of 82% using RNN. For the future work, several possibilities can be explored to enhance our model's performance. Creating more cyberbullying annotation guidelines, collecting and annotating larger data sets, building more different architectures for deep learning and more tuning. Finally, considering emojis as features.
This is our system pipeline. First, let's enter the model number. Let's go with RNN. Next, it shows the selected model structure. Now let's enter a comment. This is a real comment, a very devastating one. It says, "Majid, fat, and ugly. It'd be better if you commit suicide." Then the comment is pre-processed and numerically represented to be fed to the model. Then it finally outputs what class it belongs to.